Hello, my name is Brian Parks, and I'm a senior in computer engineering at Kansas State University and the president for Wildcat Rocketry. This will be our team's 7th year competing at the Argonia Cup and our 2nd attempt at a 2-stage rocket. Much of our rocket design has been overhauled since last year to better fit this year's competition objectives. We are very excited to show you what we've been working forward towards this year.
Hi, my name is Adam Rickman, and I'm a sophomore in mechanical engineering. And this year, I helped model the Argonia Cup rocket. When we first started the design for the rocket, we wanted our team to have a very clear understanding of the rocket's goals. After several meetings, our team decided that we wanted to build a smaller diameter, lighter, but higher flying rocket than ever before on our team. This year, with the rule change, having a payload of around 10 golf balls. We then took this idea and went into Open Rocket, where we were able to try out many different sizes of body tubes for both diameter, length, as well as find different geometries on fins, different numbers of fins, and many different motor configurations to find out what idea we felt had the best chance for success. We then took this idea from Open Rocket and moved it into SolidWorks, where we created a full 3D model for every part, which includes every body tube, centering ring, and many more parts, where we can then ensure that we did not make any design errors, such as overlapping parts or parts that have impossible geometries to manufacture. And in doing so, we can ensure that we will have as smooth of a build process as possible.
Hello there, my name is Billy Emick, and I'm a senior in mechanical engineering. I'm also this year's Argonia Cup competition manager.
Greetings, my name is Philip Shirky. I'm a junior in mechanical engineering and the vice president of Wildcat Rocketry. Our rocket's airframe features the most significant changes in comparison to last year's rocket. This was a year of growth for our team as we pursued multiple research and development projects alongside our work with the Argonia Cup. One of these projects was research into better fiberglass and epoxy mixes to improve our construction methods going forward. To maximize our chances of success in this year's competition, our team opted to use commercial fiberglass body tubes instead of relying on our traditional in-house construction methods.
Based on our simulations, our team opted to use Wildman Rocketry's 2.6-inch custom commercial fiberglass body tubes, as we believe these tubes would allow us to obtain the heights we desired, while also allowing us to carry the number of golf balls that we had planned for in our simulations. Our body tubes, switch bands, couplers, motor mount tubes, and nose cone are all commercial this year, but many of our components were still made in-house by our team, such as our bulkheads, centering rings, and switch bands.
Hi, my name is Logan Gamble, and I'm a senior in mechanical engineering. The one part of our rocket that stayed the same this year, same as last year, is our electronics and flight computers. For the sustainer, we'll be using a Telemega, and this will be controlling our motor ignition, main parachute deployment, data recording, and communication with the ground. And as a backup system, we'll be using an Easy Mini. This will be mainly just firing our backup ejection charges. And for the booster, we will be using a similar setup with a telemetrum as the primary flight computer, firing the main ejection charges. And again, as a backup system, we will be using another Easy Mini, and this will be firing the backup ejection charges for the booster.
My name is Ben Monday, and I'm a sophomore in mechanical engineering. This year, our team selected an Aerotech L1000 motor to guarantee a fast and stable launch off the pad. About 3 seconds after launch, our Telemega will attempt to light the second stage. This year, we programmed in multiple conditions, all within competition rules, to increase the likelihood of second stage ignition. If second stage ignition is successful, a K270 Aerotech motor will then take our sustainer at just under Mach 1 to a height of 17,500 feet.
My name is Jake Hajduk, and I'm a junior in mechanical engineering. One of our biggest focuses of this year's rocket is its recovery system. After all, if we can't find a rocket, then we can't win the competition. For our booster, we have equipped a 40-inch parachute that will deploy at the booster apogee, and in a similar vein, we have equipped a 20-inch drogue parachute on our sustainer that will deploy at sustainer apogee, along with another 40-inch parachute that will deploy at 1,200 feet altitude to ensure that our sustainer falls at a comfortable 26 feet per second. To actually record and track the recovery of a rocket as it's falling, we will be using a pair of tele-BTs that are synced to our booster and sustainer primary flight computers.
Hi, my name is Cole Shear and I'm a sophomore in mechanical engineering. Throughout our construction and testing phase, we encountered many problems that required us to make on-the-fly adjustments to our rocket design, which test our engineering skills to the max. During our first ejection test, the charge blew out our bulkheads, and we had to design and print a piece that would allow us to bolt the bulkheads directly to the airframe, reinforcing our existing epoxy connection. Another problem we encountered was the lack of room in our parachute bay. To solve this problem, we simply tacked on some old scrap pieces to the end of our tube and reinforced it, which gave us the required space. Finally, during one of our early flight tests, we encountered a corkscrew with the rocket. To solve this, we simply injected some tungsten powder into the base, which lowered the center of mass, giving our rocket the required stability.
We would like to thank the Cloudbusters for hosting this unique competition. We are fortunate to have the rocket pasture so close to our campus, and we appreciate the support that you give us, other collegiate teams, and the rocketry community as a whole. We look forward to seeing what other teams bring to the competition. And as always, see you at the rocket pasture, and go Cats!